Hello again, physicists. Today, I have a presentation for you related to what will become ultimately maybe our most important tools that we use in a lab setting. Keep in mind that in AP Physics, we're going to be doing a lot of inquiry-based investigation. This means you're actually going to do a lab procedure to draw a conclusion that is relevant to the content that we're learning in class. And then we'll kind of go back and refine our discovery after the fact. So that means that we really need to make sure we're prepared to know what the tools will be that we'll be using during these labs and how to use them appropriately. So that's what this video is all about. I'm giving you a tutorial into two major things. The first being probeware. You can think of this being the software, or not the software, but the hardware that we're using throughout the year. And then the second part we'll be looking at what is Logger Pro, which is the software that goes with all of our sensors and our Lab Pro. So our first picture here is demonstrating one of the many probes that we'll be using throughout the year. And a probe is anything that's going to collect data, measurements of a quantity for us to use. And we have probes that can measure motion, we have probes that can measure force, we have probes that can even measure things like electricity or temperature. But for kinematics, our main probe that we'll be using is this guy right here, the sonic motion sensor. And if you've ever heard of echolocation, what bats or what whales use to find their way around, the sonic motion sensor works in a similar fashion. So the sensor will send out a series of sound waves, and they'll travel out in a cone shape, kind of like this. And then we'll have our sound waves within that cone. And if something blocks those sound waves, like a person, hello, what will happen? Well, some of those sound waves will bounce off the person and travel back towards the sensor, and they will be picked up by the sensor. And by knowing automatically what the speed of sound is, the sensor can then determine how far away something is from its position. And it allows you to actually then plot things like position, and then from there determine things like velocity and acceleration. So that's why the sonic motion sensor will be a significant tool for us, specifically in kinematics, when we're looking at things like position, velocity, and acceleration, and how they're all related to one another. All right, another component of hardware that we will be using right off the bat, and in fact we'll be using in every single investigation where we have probeware, is called the Lab Pro. This guy right here, this big green box. You can think of the Lab Pro being like a middleman between our computer and our sensors. A lot of the sensors we're going to use can't be directly hooked up to the computer. So this acts as a glorified adapter. And on the Lab Pro, you have a series of ports. They're currently not visible in this picture, but they line the left and right side of the Lab Pro. And these ports allow you to hook up multiple sensors at the same time. Now you'll notice that there are a whole bunch of different wires coming out of the Lab Pro, and I'm just going to quickly illustrate, where these wires go, what they're doing. So in the back right-hand corner, you can see that we have this cord coming out with some red tape on it, and this actually is going to the wall. This is the power source for the Lab Pro. So if your Lab Pro is hooked up to your computer and it's not showing any sort of lighting, like this little light right here, it probably means that it's just not plugged into the wall. You don't have any power for it. So you do need to make sure that you hook your Lab Pro up to an external power source. Okay, on the left-hand side, you'll see here that we have a black USB cord coming out, and that is what hooks the Lab Pro up to the computer. So you need to have your Lab Pro hooked up to the wall. It also needs to be hooked up to the computer. And then our last cord, which is right here, this is a cord that leads to a sensor that we have hooked up. And in this case, it's the motion detector. So this gives you an idea of the connectivity for the Lab Pro to all the different components that are involved. And again, we're just looking strictly at the hardware aspect here. So now that we've taken a look at the hardware component of our tools, we're now going to look at the software component. And the name of the software we will be using throughout the year is called Logger Pro. So this is just going to show you a couple of screenshots of where Logger Pro is and kind of how it looks when you open it. So on our desktop, right here, the icon that I am circling is where you will find Logger Pro. We're using version 3.9. And when you open it up, you should get a screen that looks something like this. So you can see that at the top, I know it's a little fuzzy, I apologize for the resolution here, but we have your standard tabs where you can select different options. We have a few shortcuts here. We have a big green button, it says collect. And then over here is where our raw readings will be displayed. In other words, every single individual data point that's collected will be shown here. And then in this case, we already have some graphs that have been displayed for us. So that's how you open Logger Pro up, and this is what you'll see the first time that you open it. Once you have opened up Logger Pro, every time there are a couple of things, a couple of procedures we will want to follow to get ourselves situated before we even think about collecting data. The first thing we will always want to do is make sure that our Lab Pro has been identified and that we have at least shown that the sensors we're using are indeed connected to the proper channels. So to do this, I would click on Experiment here at the top, and I would go down to Set Up Sensors. And if my Lab Pro is connected properly, it'll show this right here, Lab Pro 1. And when I click on that, I then have this window here pop up, and you can see it gives me a picture of the Lab Pro as well as some white boxes. And each of these boxes represent one of the channels or one of the places where I could plug a sensor into my Lab Pro. In my actual setup, I have a motion sensor connected into the digital Sonic 1 port. And as you can see here, it's actually showing that indeed I do have a sensor hooked up. So this is a good thing. This tells me that my sensor is connected to the right port and that Logger Pro is reading it and recognizing it. If it wasn't like this, I would have to click on this box and then I would have to select a sensor, and there would be a drop-down menu that would allow you to choose the appropriate sensor. So before we collect any data, every time we need to make sure that the Lab Pro is recognized by the software and that it's also showing the proper sensors hooked up in the proper place. Now that we've verified that our sensor is hooked up properly to the Lab Pro and the Lab Pro is being recognized by our software, we may begin collecting data. And to do this, you would click on the green play button here at the top, and next to it, it says collect. So if I were to click on that, it would actually start determining the position and maybe some other things of something sitting or standing in front of my motion sensor. And it would plot in real time those values as a graph. After hitting the collect button, here's an example of a plot that may have been made as a result of data collection. You can see over here in the left-hand part of the screen that we have a whole bunch of numbers, and these numbers going across represent individual data points that have been created by the sensor. And over here we have two different plots. This plot is of position versus time, and you can see the red line represents all of those data points on my graph. And the second one is velocity versus time. Now there's an important thing to recognize here. It says that my position, and I was actually standing in front of the sensor when I collected the data, It's saying that my position is about half a meter away from the sensor, that I was standing about half a meter away from the sensor. Truth be told, I actually wasn't. And I'm going to show you how you can correct this issue in my next picture. So as you saw in the prior picture, I made a graph. I was standing in front of my motion detector and it plotted my position and my velocity with respect to time. However, the information that was being plotted wasn't necessarily true. I wasn't actually, around a half a meter away from the motion detector. The way we're going to get around this, and this will be true for pretty much any sensor that we use, we're going to have to actually zero out our sensor before we collect data with it. The way to do that is to go to Experiment, and then the second to last option is 0. And if I click this option and I stand in place in front of the sensor, it's going to now say that wherever I'm standing in front of the sensor while it's being zeroed, that will be a position of 0 meters. And any other position will be measured relative to that starting point. So it is essential that we make sure that we are zeroing our motion detector before we actually collect meaningful data. What are you seeing now is a series of data collections after I zeroed the sensor. And when I recollected my data after zeroing, I didn't move. I stayed in the same place, which meant as long as I was stationary the whole time, it should have read that I was at a position of 0 meters. And as you can see, for my position versus time graph, I was indeed graphed to be at 0 meters the entire time. And this is a quick, easy way to verify that my sensor indeed did zero out. So with this in mind, what I would probably want to do is just mark off on the ground where I was standing when I zeroed my sensor, and always start there so I know that I'm starting at a position of 0 meters whenever I collect data related to motion. So now, here's an example where I was moving as data was being collected. You'll note that at time 0 seconds, I was pretty much standing at my starting point of 0 meters, and that as time progressed, my position changed until eventually I stood still about 5.5 meters away from my starting point. So what I can do now is I can take this graph and I can actually have Logger Pro do things for me, such as take the slope of a portion of this graph or even get the area underneath of it. So for the first example, I'm going to show you how to take the slope of this example graph. Now the first thing would be, whatever region I'm interested in, I would have to click with my little cursor, which you can see the cursor down here, and then I would click and drag so that my area of interest would be highlighted gray. And what this does is it tells Logger Pro, hey, I only care about taking the slope of this part of the graph. I'm not worried about, anything that happened out here. And then to actually have Logger Pro take the slope, what I would do is I would go to the top, and where these shortcuts are located, I would want this icon right here, and as you can see, it pops up and it says Linear Fit. And what Logger Pro will do when I click this button is it will automatically put in a best fit line for the shaded or the highlighted region of my graph. And after clicking it, here's what I have. So you can see here that we have our linear fit going right through here. And again, it's only applicable for the gray portion of my graph. They tell you the general form of the equation for this linear fit, as well as what the slope is with units. That's very nice. And they'll also give you a y-intercept should it exist. Now you'll notice for my particular y-intercept, it's very tiny. In fact, it's almost 0. Why? Because the y-intercept in this case is just telling me what my position was when the motion detector started collecting data. Sorry there. And if you kept in mind, I started at approximately a position of 0 meters. So it makes sense that my y-intercept is just about 0 meters. So there you go, an example on how to get a linear best fit curve for Logger Pro. As I mentioned in the dimensional analysis video, every once in a while, we won't want to look at the slope of our graph, but instead look at the area underneath our graph, because sometimes that can have physical meaning as well. Guess what? Just like Logger Pro is able to give us automatically a best fit line for our graph, Logger Pro can also automatically find the area underneath a graph for us as well. So to do that, you would come up again to that shortcut bar, and instead of doing the best fit line, you would choose the option immediately to its left. And if you hold the cursor there, this will pop up. It'll say integral. And this is the fancy pants calculus way of saying take the area underneath the graph for me, please, Logger Pro. And if you click on it, Logger Pro will say, sure thing, mister. I'm going to take that area underneath the graph for you. And then this is what will pop up. So here's the same graph from the prior example, but now you'll notice that we have this highlighted red region, and this represents the entire area underneath our graph, just for that pre-selected shaded region. And you'll see that here is the area that it took, and they even give you units for that area. So the cool thing with Logger Pro is whether you're doing a best fit line and a slope or you're doing the area underneath, it automatically does that dimensional analysis and gives you the units. Therefore, all you need to do to get physical meaning when we graph in Logger Pro is just look at the units it's giving you and figure out, okay, well, what quantity is associated with those units. This is a nice feature in Logger Pro that will save us a lot of time and really allow us to think conceptually about the consequences of what we're seeing in our inquiry-based labs. Last thing before I let you go. Every once in a while, life is made easy for us. And all we really need to do with our graph is actually make a reading off of it. To do that in Logger Pro, we're going to go one more space to the left on our shortcut bar to right here where it says Stat. And what this will do is for any highlighted region on my graph, it'll give me the statistics for that entire region. If I click on that option, this is what comes up. So all this does is it tells me from 0 out to 2 seconds, it'll tell me what my average position was, that's what the mean would be, as well as what my middle position was, which would be the median. So you would use these two pieces of information most of the time to get just a straight reading off of the graph should you ever need it. If I wanted to know specifically what the reading was at a very particular time, say like 1 second here, then all I would do is I'd highlight a very narrow region and only this little piece, this little sliver would show up gray. And then when I hit statistics, it would just give me again for that very small area, what is my specific reading. And that pretty much summarizes everything, folks. Be ready when you come back to class to just hit the ground running with this stuff. That's why I'm spending a whole video just explaining Logger Pro, because we're going to use this to make graphs of motion, and we're going to basically spend all of our time making graphs, interpreting them using Logger Pro, and thinking about the physical meaning behind things like slope and area and readings, and how we can take a graph and describe in words what the graph is telling us about the motion of an object. So with that said, physicists, make sure you get all the notes that you need, and until next time.